Okay, thank you everyone for joining the Magma Town Hall. My name is Ben Sternthal. I'm going to be helping to moderate this town hall. I work for the Linux Foundation. Magma is one of the projects that I work on. Just a quick note about the Linux Foundation. It not only does it help with Linux, but it helps with, well, almost 100 or so open source projects. And if anyone is interested in finding out more information about the Linux Foundation, I would encourage you to check out the website. There's links to jobs, training, events, and all the projects that we support. And it's a great resource. You can also reach out to me if you have any questions about the foundation via Slack or email. I'd love to chat with you if you're interested. But for today, we're here to focus on Magma. And first off, I want to thank all the attendees who are joining, as well as the presenters. We've got a wide variety of time zones here, which is pretty cool. It's a really interesting agenda today. We've got 5 presentations. So starting us off will be Shah Rahman, Director of Engineering at Meta. He's going to talk to us a little bit about, he'll be doing our keynote and talking to us a little about the history of Magma. Next up will be Joel Donovan, I'm going to try to get everyone's name right, CTO of Watch Communications, and Hjordon Vertanowski. I think I got that pretty close, right? Chief Architect at Connect 5G, and they're going to talk us through a commercial implementation of Magma. So that should be really interesting. Next up, and I'm really excited about this one, we've got Jim Blakely from Carnegie Mellon University, and he's going to talk about Magma and the Living Edge lab network that they have running there. It should be really interesting. Next up, we've got Javier from Yota de Nicaragua, and he's going to talk about a small commercially deployed network. And then finally, we're going to hear from Jordan again and Yogesh from Wave Labs, who are going to talk about next steps with Magma. I would encourage people to ask questions. There's a Q&A feature under the chat, and I'll be helping to moderate those and making sure that we answer everyone's questions. And if you run into anything, you can private me, and I'll try and make sure that your question gets addressed. But yeah, it's a really jam-packed town hall. Thank you everyone again for coming. We hope to do these regularly. And with that, I'll pass it on to Shah, who will kick us off.
Thank you. Thank you, Ben. Can you all hear me okay?
Yep, I can hear you.
Okay, fantastic. Hey, it's a great pleasure to be here, and thank you for inviting me. It's I always get excited to talk about Magma because it's been so long, and there's so many interesting things that have happened over the years. So when Som talked to me about possibly talking about a little bit of the Magma history and how it started, where we've been, and kind of like I would say how we got here. Yeah, it was very exciting for me. So because a jam-packed agenda, let me just jump right into it and start by saying that when Magma started with a small acquisition that Facebook made back in 2016, early 17 timeframe, out of the University of Berkeley, and the goal at the time was to see how can we get high-speed internet over 3G networks. You heard me right. It was over 3G networks. And you might ask exactly what was the use case for that? The use case was pretty simple, that when you go to like the developing countries and rural places that at the time did not have the 4G networks rolled out, and the network economics did not work in many of those cases, whether it's because of low population density or because of the lower income levels. It was very difficult to get any reasonable network coverage or any sort of, like, I would say, high speed, forget high speed, like reasonable speed network coverage for those areas. So the idea started by basically saying, how do we add data networks to 3G networks? And that's when the Endaga, the small acquisition that came into Facebook, a group called Facebook Connectivity, and that's when the Magma journey started. But very soon, the team realized that trying to retrofit a high-speed or reasonable speed again network into 3G was not easy. There were a lot of different kind of complications, and getting internet to work over the various networks protocols at the time was very, very difficult. And so they sort of pivoted over from Endaga to Magma, and they started working on what they call the long tail of the 4G or the LTE networks, where and how you can actually get good internet connectivity, which really has become like it's a basic necessity for people and enterprise around the world, right? It's just a you know it's needed. Just like we think about water and electricity, we think about the internet, right? And that's exactly how Magma started to kind of figure out how we build a slightly different version of, I would say, the cellular networks that you could reach these difficult to reach places, whether they're like remote or rural, and so on. So when we get to when we got to like about a year or so to kind of like understand how do we want this this technology to be built and how do we want them rolled out, there were like a team got put together into a group called Facebook Connectivity, and that's when I would say that that's the group that was looking at these various alternate network access we call. There was like a balloon project, like I'm sorry, not the balloon project, the drone project. Balloon was Google, in kind of like around the similar times. But we had like a drone project that would fly the drones, high altitude drones and provide connectivity. We had another project called Telegraph, which would provide gigabit level internet to the street levels. So we say Magma is going to be a complementary cellular technology which would actually be standard compliant, number one. Number two, it would be very seamless from a wireless or radio access perspective. So cellular would be the primary mode, but then it could also support Wi-Fi. It could also support satellite. It could also support telegraph. There was also like this, all the different kinds of radio. So really a radio agnostic core network that would have the proper AAA functionality, that would have the proper policy enforcement functionality, billing functionality, and then how do we do it? So at the time, team got together and pretty much built a ground up architecture for that, the core network basically, that had an access gateway, that had a federation gateway, and that had an orchestrator. So these three components. And that's sort of like how Magma started, many years ago. And and it used some of the very interesting design principles. For example, a lot of the ideas came from using SDN and using like software-defined networks, using software controllers, using leveraging cloud to be able to scale as you go, leverage a bunch of open source components, right from Open vSwitch to gRPC to Kubernetes to Prometheus. It's just a very wide variety of different components into what people came to call the cloud native network. But this was way ahead of like 5G cloud native or that sort of thinking at the time. And we were able to leverage these principles to build out the initial version of the Wi-Fi, I'm sorry, Magma, that supported both Wi-Fi and LTE. And later, it also supported 5G that was built later, right? And we know there are some important differences between LTE and 5G architectures. And it took us a good few years to really get the 5G architecture on the call had participated in that. So that's sort of like how the genesis and starting of Magma. So let me talk a little bit about how we thought about the vision. Like, what would Magma really do? Why? Okay, it's great. So now we got this long tail rural and remote networks to be supported by a radio agnostic, core network. What is it going to be like a few years from now? Why would we actually, continue to support it from Facebook and Facebook connectivity perspective? And that's when we realized that there is a broader opportunity or movement to really try and get open source components or open source software to be a lot more prevalent in terms of doing like dramatically reducing the network TCO and thereby really cost of the running the networks and thereby eventually have um, the subscribers or users on the network to be paying hopefully a lot less than what the regular cellular networks would offer. Right? That was how do we an open source telco or open source 5G plus movement, right? And we know that that has happened like in the enterprise, broadly speaking, over the last few years, right? And if you think about Google, Facebook, Amazon's of the likes, or Red Hats of the likes, we started seeing that sort of movement in, I would say, 2018, 19, and into the pandemic with Geo, Rakuten, Dish Wireless. They started leveraging more and more open source products into their networks. So that's when we felt that in 2021, when we formed the Magma Core Foundation, it was formed with basically that vision that how do we really have Magma Core to become that one open source core implementation that is a converged core that can support different generations of networks or different RAN agnostic. It would be cloud native, so you could basically really have all the components that you could seamlessly run in a public cloud, in a private cloud, data center, what have you. And then finally, it would be also be multi-tenant, right? So that's how we kind of thought about the vision that Magma would become, and over the time, we really looked at the project community fit. Once we had the Magma Foundation formulated, over the past couple of years, we had many tens of contributors. We had thousands of commits started coming in. Excuse me. And Facebook gradually started sort of like getting this project over to Linux Foundation. And then I think we found pretty reasonable product market fit in terms of whether it's decentralized networks, whether it's rural access networks, whether it's private networks that are in enterprise or campuses and so on. We got a pretty reasonable product market. We saw several organic adoption, which I would say very small amount of marketing and promotion, right? So I think that's the power of the ecosystem of that Magma was able to build, whether it comes to uh, between the vendors and operators, the academia who participated, the industry groups that we were working closely with, for example, TIP, and then finally there were several startups who actually leveraged Magma and to build a product. And it really was pleasing to me to hear people's stories, how they got Magma up and running, and then how that helped them bootstrap their startups. That was super useful to hear. And there are several examples that I can think of. So really going forward, what I kind of always felt, or the team who started this, whether it's Amar, Shadi, Brian Barry, there's like a long list of people that I could go on and on. Like many people from Facebook, from other companies, from academia have participated over the years. And really, we are, like I would say, in this value market fit phase, right? I mean, we got the project community fit. We have a thriving community. We have the reasonable product market fit. I'm just using the word reasonable because there's not a whole lot of commercial, I would say, large scale commercial success. But then usually that's more of scale and growth type of phase, not so much product market fit. But we have a solid product market fit, and now we're in this phase of the value market fit, and that's where I think this community, that those who are looking at this, and let's hear from others about how they're leveraging the Magma substrate and really looking at whether to some of the things that we see is like commercialize Magma with enhancement support services, or leverage Magma for enhanced emerging connectivity use cases, whether it's an edge case, IoT, decentralized, or maybe offer Magma as a service with hosting, tooling, and commercial operations, or leverage Magma for consumer or enterprise use cases, right? There's a private network, especially with the advent of AI and AR/VR. We believe it's going to be probably an excellent open source commercial core, because we are not aware of any others who are as commercially deployable as Magma is, right? There's many academic examples, but we don't believe there is one that you can actually deploy and crash production traffic and so on, right? So that's kind of where we stand. That let's see how we can possibly see the value market feed phase with Magma for years to come, so that we can with our 4G support, 5G support, Wi-Fi support, we can really see these different Magma use cases grow and thrive. Okay, so I think that's where, reflecting on the past, thinking about the present, and projecting to the future, it makes me immensely proud to see how far we've come. But I believe that we have a long way to go from here as well. Okay, So with that, let me hand over to Ben, and look forward to hearing the rest of the presentations. Thank you, everybody.
Thank you, Shah. Appreciate it. All right. So next up, we've got Joel and Jordan. And Joel and Jordan, I would ask that you do also introduce yourself, just in case folks forgot for my initial intro. It'd be helpful. So thanks, guys.
Sure. Jordan, if you want to go first, I'm going to be talking a lot. So.
Okay, so let me talk first. Hi, everyone. My name is Jordan Vertanovski, or Jordan Vertanovski. And I'm the chief architect of Connect 5G. Here I'm with Joel, and we are going to present to you how we have deployed Magma in a commercial environment. Joel?
Okay, so I'm Joel Donovan. I'm the CTO for Watch Communications. And I've been with the company for 20 years. I originally managed our first broadband high-speed internet deployment back in 2000. Well, it started in 1998, but I managed it about 5 years after its inception. So I will get started if you guys are ready. Watch Communications is actually our DBA name. The original business name was Watch TV, and it was an acronym that stands for Wireless Approach to Cabling Homes. The company was established in 1992, actually as a video service provider. Our parent company, Benton Ridge Telephone, has been around for over 100 years. So we're a well-established company. Benton Ridge Telephone is a small independent local exchange carrier telephone company in Northwest Ohio. But the original reason the company was founded was to basically replace off-air antennas in rural areas. There was no DirecTV or Dish Network or anything at that time. People just had an antenna on their home. That's how they picked up broadcast television. So we launched a kind of a meager 12 or so channel video service in 1992, and we eventually grew that service to about 130 channels of digital cable. That was all before the internet was a thing, and so when the internet started kind of catching on, we launched an internet service around 1998. We also have a sister company called Community Fiber Solutions. We've got about 160 miles of fiber that we built in eastern Indiana that we operate as well. But like I said, starting in 1998, that's when we launched our first internet service. We did a DOCSIS-based system. We kind of gets referred in the industry as WiDOCS, where we were deploying cable modems and up converters to up convert the signal from the cable modem into the 2.5 gigahertz spectrum that we owned at that time. So many other access platforms that we've deployed over the years. We deployed WiMAX, multiple proprietary fixed wireless technologies. Our foray into LTE started in 2016. We deployed Telrad Networks, an Israeli company. We deployed their LTE platform, and they had their own core solution. And then in 2020 is when we deployed the Ericsson equipment that we're operating today. We deployed an Ericsson core. We have 850 or so transmit sites across the region pictured here in the map. About 150 of those sites are operating Ericsson equipment. So we operate in those in the blue areas pictured here. We've got about 25,000 subscribers. We're very heavily rural. Probably 95% of our subscriber base is in rural areas. So we're really going out to the edge into the country where people don't have a lot of options. And Shah was talking about the economics that speaks directly to our business. It's challenging when you've got a coverage area where you may have just a couple homes per square mile. Economics become obviously very, very important. So we operated with the Ericsson core for a few years. This is a slide that I presented to our internal staff in staff meetings to kind of give a clear picture of the pros and cons of what we've dealt with moving from the Ericsson core to Magma. So the Ericsson core that we're operating in one of our data centers, we have two full Ericsson cores. It's over 200 virtual machines, multiple physical servers that those virtual machines are distributed across. All of those machines are individually managed. It requires major traffic aggregation since we can't afford to deploy a lot of cores. We've got two core locations, so that entire multi-state network really has to aggregate back to just one or two locations where our cores are. It's very complex. We rely very heavily on Ericsson for support. most of the tier 1 carriers that are working with Ericsson kind of throw money at their problems. They may have a staff at Ericsson that just manages their network for them. Being a small company, that's a bit of a challenge for us. So it's been cumbersome. It's been challenging to get good support. 5G support, as we were looking at it, is very expensive. It'll take a long time to deploy. So this painted a very interesting picture to our operations staff, kind of contrasting, where we're headed and the capabilities with Magma that what Connect 5G has done to adapt it to run on an ARM architecture. Essentially gives us the ability to fit the functionality in that entire rack of equipment into a device that fits in your hand. Now, we wouldn't go to production at a large scale with that ClearFog device, but just to give people an idea really of how revolutionary this is and how important it is to our business. So the present is our Ericsson core that we've been operating for a few years. The future is Magma. We're about 30% migrated over to the Magma platform today. The benefits, capability of deploying to small distributed devices, centrally managed via a web interface. Like I said before, we really heavily relied on Ericsson for support. So for us to have the orchestrator interface, to be able to do more of our own troubleshooting and get really granular, meaningful information at the tip of our fingers very quickly. The flexible network design that it allows. So since we're no longer locked into just 2 cores that we were operating previously, I'll get into it here in a moment how we're going to be distributing our cores, and 5G support, which is it's wonderful to have that already built in, and we're planning on testing that shortly after we complete our production migration. So picture on the right is the ClearFog device that we piloted with, and then below is the Nexcom NSA 6310 device. It's a 1 rack unit device that we can operate 4 cores on that device. So that's what we're going to production with. So we are deploying in phases. Our first phase, pilot phase, lasted about a month. We deployed that ClearFog, very small device, in 2 different locations just to verify the stability of the platform. And we did go to production with a couple of sites in southern Indiana. Went very well. The migrations went very well. So we moved forward with the purchase of those Nexcom servers, and we're now in phase 2, which is our Ericsson core replacement. Phase 3 will be a fully distributed core. So once we have all of our 150 Ericsson sites transitioned to Magma, we'll begin the process. Today we're centralizing 8 of those Nexcom servers at 2 different locations where we currently have an Ericsson core. Once the production migration is complete, we'll distribute those devices to other points in the network, which will save on some transport costs and give us a little bit more flexibility. So in terms of the selection of a partner, we chose Connect 5G. We had an established relationship with them in that they were providing consulting services and optimizing our Ericsson network. Very capable team of people, a lot of experience. They were flexible, working around our schedule, and just a great team, very resourceful, very approachable and responsive. So we're deploying Opus Magma 1.8, so that's the hardened version that Connect 5G is adapted for the ARM architecture. It's a Dockerized deployment with ARM 64 devices using Kubernetes and libvirt KVM virtualization. So I'll hand it over to Jordan. Jordan, if you don't mind, to go into the architecture.
Yes, so a little bit about the architecture and how we deployed Magma on the NSA devices. So we have built the in-house Kubernetes cluster. We built it on x86 servers. We had 3 servers, and then we ran 2 virtual machines on each. Actually, 3 virtual machines on each of these x86 servers, out of which 3 virtual machines, 1 on each server, are serving as the management nodes. We have 1 worker node on each server as well. And then we have some supporting function nodes like the Docker repository, the backup management system, and then device which is, or instance which is managing all this infrastructure. On the AGW side, we have prepared these NSA devices to be able to deploy 8 virtual machines, out of which 4 are actively running and 4 are standby. This big device, the 1U devices, they have 8 10G interfaces. So we have split these 10G interfaces into bridges, and these bridges are responsible. We have 4 bridges for RAN traffic and 4 bridges for SGA traffic, and the virtual machines are sitting on across the 2 of these bridges, and we are able to move virtual machines from one bridge to another bridge in case of if we need to do some failover or we need to redivert the traffic through different routes if we have congestion which we cannot solve with the transport itself. And then we have a special admin bridge which goes across each of these virtual machines, which allows us to access the CPs and manage the CPs directly on the directly from the network instead of trying to use remote management systems for the CPs. Yeah, usually we can go back to you.
Okay.
This is, yeah.
Yeah, so I can kind of step through the phases of our deployment. I mentioned earlier that we selected 2 pilot sites where we deployed these solid run clear fog devices. Orchestrator was deployed on an AWS cloud temporarily so that we could access it, and then we had 3 active sectors on an Ericsson ENB. We had 50 subscribers, so we did kind of a production migration over to Magma, and we ran that in total for 4 months. No incidents, no downtime. I think at one point it was a little later in the process when we did a migration, and I got yelled at for jinxing it when I said, "Is that it? Like we're done?" When we did a transition. So the platform's been really solid. It's been really reliable for us. So we're really happy with it. So the production phase that we're in now, the first phase of that is, like, as I said earlier, basically to replicate the Ericsson core that we have today. So we have 8 NSA 6310 servers. We're distributing, 4 each to the 2 locations where we have an Ericsson core today. And then Orchestrators deployed on a private Kubernetes cluster on some servers in our data center that we own in southern Indiana. So of our 150 sites, we organized those into 50 clusters. We imported all of our SIM cards. We got about 16,000 SIM cards. We've got, some of those are for our other LTE platforms, like Telrad. So there's 3,500 active subscribers today on our 150 Ericsson towers that we're going to be migrating to the Magma platform. And then we have plans later on to deploy the rest of our LTE systems as well. So focused on Ericsson in this first couple phases. So phase 2, which we expect to happen next year, we will be geographically distributing those servers to 6 different locations in our network that are kind of aggregation points. So that'll give us, as I said earlier, that'll give us the ability to basically not be aggregating so much traffic to those 2 locations. We'll save on some transport costs, as we have a couple other points of presence in data centers where we have upstream connectivity. That will prevent that traffic from having to be hauled back to another location to get to the internet. And then a migration of those about 3,000 legacy subscribers on our other LTE platforms. So if I'm speaking about strengths and I won't say weaknesses, but improvements that I would like to see as I was thinking through this, the obvious things are the management interface. As I said before, we were heavily reliant on Ericsson to really support any problems that we had. Basically, as soon as we had an issue, we were having to escalate to Ericsson, and they weren't as responsive as you would hope. So being a small company, having more capabilities internally to troubleshoot problems, to see why why a UE is not attaching, and get some diagnostic data is really valuable to us. Provisioning is much easier. We had an API that we actually developed in-house that interacted with the Ericsson core. Very quick and dirty, and error prone, and prone to human error, things like that. So the much simpler IMSI provisioning and HSS profile assignment in Orchestrator is our operations team can't wait for this deployment to be done. Dramatically lower administrative overhead and cost, really, from those first 2 factors. Just it's much easier to manage the core and therefore the network, provisioning new subscribers, doing upgrades and things like that. Faster deployments. I mean, this is kind of forward looking, but I really expect as we turn up new sites, that process is going to be a lot smoother. not only getting the sites integrated into the core, but anyone that's operated an LTE network knows that, you know, if a device isn't attaching, you don't always get really useful information from the platform in terms of why. You know, signal levels look good, but the device is just not attaching. Now we can look at Orchestrator and we can see the event history. We can see why the device isn't attaching, if it's an authentication issue with the SIM, that kind of thing. And then 5G support. I'm really enthusiastic to test 5G once we have our production migration completed. So if I'm looking for improvements, really, if we could leverage the name field in Orchestrator for identifiable data. I mean, we can populate it today, but having the ability to search that field would be helpful. We kind of have to maintain an external database of IMSIs and to look up who has what IMSI and, you know, find a subscriber. So having the ability to put an account number or agreement number from our billing system into Orchestrator, search by that field, would eliminate the need for that secondary database. Also, wildcard searches would be helpful. Right now, we do an IMSI search. You need to put on IMSI in the full 15-digit IMSI code. So not a huge deal, but it would be obviously convenient to do kind of an asterisk and last 5-character search or something like that. Active Directory LDAP authentication. I think Jordan mentioned that this is actually a feature, just not well documented, but it would be nice if we could leverage. We use Active Directory and LDAP for the two are integrated in our network. So we do a lot of single sign-on and centrally managed authentication. So it would be nice to not have kind of the standalone requirement of having individual users in Orchestrator. And then handover, you know, that's really the only problem that we've noticed as we've done this deployment is when there's a handover that spans to another AGW. Like if there's 2 sites and one of them's on a different AGW, if there's a handover event of a UE between those towers, that process is not real smooth, and we've had to kind of do some manual resets of equipment and cell locking and things like that to overcome that issue. So that's what I have. I think we left a little bit of time for questions. If anybody has any questions for me or Jordan as it pertains to our deployment.
No, this is wonderful to see. I mean, thanks a lot for sharing the details and
Sure.
and being so excited about 5G. And yeah, look forward to hearing the rest of the production deployment, how that goes. And yeah,
Absolutely.
maybe the only question I have is on the improvement sides that you described. Is there any activities or movements in the around those?
Well, we're really focused on the deployment, right? So it's so much better than what we have. We're really not focused that much on the shortfalls. It's honestly just been if I have to think of something that could be better, this is it. And you know, hopefully there will be some movement in the next month or two on some of those items. But we really haven't. Our operations team is just chomping at the bit to have this done, just because they're very happy with how much easier it is to manage. So that's kind of where our focus is today.
Okay, sounds
like
good. So we look forward to hearing the rest of it.
Yeah, it looks like Lucas had a question about handover issues. I don't know how far I can go into the details. Jordan, do you have anything else to add?
I mean, when I can add a little bit. Sorry, Lucas, I have not seen the question. It seems that they are not coming properly to my side here. Anyway, yeah, the handover. It's the problem when you're handing over between 2 AGWs. Is actually at the end of the day you are ending up with tearing down the connection and losing the IP addresses and the whole context from the one AGW and creating a new context on the other AGW. And now imagine if you are a subscriber who is on a conference call like us now and who is in a time zone very similar to me where the people are operating and they're changing the network. At that moment, he will lose the connection and he will have some gap of a couple of seconds, maybe 10, 15 seconds, and he reestablishes everything. So it's not a very smooth experience for the subscribers. And for the radio optimization, sometimes you want to have these handovers happening more rapidly, meaning I want the traffic conditions and the radio conditions are such that maybe 10, 15 minutes he will be on one side, 10, 15 minutes he will be on the other side. And then if you do this tearing down the connection all the time on each 10, 15 minutes, it's very bad experience for the subscriber. And as Joel said, in that case, we are forced to lock him on one cell. But when we lock him on this one cell, he has a problem with the radio. When this cell becomes more utilized, or when the radio conditions are going down on that cell, the subscriber experiences problems. So handing over the context as well from between AGWs, this is something that we as a community need to start looking at.
Let's book a little slot in the next TSC meeting to talk about the architecture.
Mm-hmm.
Thanks, Joel. Thanks, Jordan. I don't see any more questions, so we're going to move on. Again, we'll have. Oh, wait, we just got a late-breaking question, and I'll also mention we'll have time at the end too. But one question just came in from David. I'll just read it since I'm talking anyway. Hello, team. How can we build a POC to have a solution to present, for example, to government?
Hello, team. Hello, team. It's David. Sorry. Well, to be honest, I am from El Salvador. Okay. Here is we are a country where there are a rural place. Okay, where that the ICPs or the enterprise that develops, or in this case, mobile solutions, obviously for them is not attractive, So if we understand this solution is to provide this kind of connectivity, okay, to that kind of place, So it's for that reason that I would like to build POC or proof of concept, then we can present to the government. Okay, so that is my question. What are the components? Presenting to me, I am a network engineer. Okay, that works. I already worked in telco companies like in United States, AT&T, T-Mobile, that provides this kind. I know what are the components for the network, or for example, the packet core nodes that and all the IP core network too that provide internet. So. But my question here is try to build a POC, okay? How to get, for example, and show the benefit that we can cover it, okay? And see, and probably the government could be attracted for them, and work on in that solution. But that's my
yeah. I mean, we are going to speak a little bit more later when I speak about our next steps. I will go more in details in what you're talking about. But we have these very small devices, which we were using in the case of Watch for the POC, and we are trying to extend this concept to the whole community. So in the next steps, we are going to announce something that will help you with that case. And then if you want partner to help you with this, I mean, we have several companies who are present here. One of these is Connect 5G. You can come to us, we can discuss, and we can help you on the plan, design, and deploy the POC, and then demonstrate it to the government. Demonstrate to the government, because you can get funding from the governments. I mean, the governments understand that they need to make to transition to this global internet, and then they need to have internet access with a good quality everywhere. So they will start putting their funds into building this type of networks.
I mentioned that because actually Starlink, that is a service that is provided Elon Musk company, it could be attractive. Here in El Salvador is for that reason that we need to have a POC that provides. Hey, you can use this solution, okay? And will probably will be more management, and because they're easy, because you have the handset that connects you to the network, okay. So it's for that reason that I would like to work in POC if it's possible.
Yes, I mean we will announce this a little bit later, and then we can discuss after the meeting. We can after the town hall or during these days over Slack channels. We can discuss how to help you to build the POC.
Okay, thank you.
David,
Thank you.
thank you for your questions. Yeah, that's great. Thank you, Jordan. Okay, next up we have Jim Blakely coming to us from Carnegie Mellon University. And again, Jim, if you would start with just a brief introduction to yourself. Thank you.
Sure, let me share my slides while I do the introduction. Can you see and hear me okay? Good? Can you hear me okay?
Yes, we can hear you.
Yep.
All right, thanks. I thought you were feedback there. Thank you. Yeah, so I'm Jim Blakely. I'm the Associate Director at the Living Edge Lab. I've been here for about 4 years now. I came before that from Intel, and before that from AT&T Lucent. So both the IT side of the tech industry as well as the communication side of the tech industry. Now I'm the Associate Director of the Living Edge Lab at Carnegie Mellon University. I'll tell you a little bit about what we do at the lab, and then I'll go into why we have a private network that we run, and then a little bit about our Magma journey over the last couple of years. So we are an edge computing research lab. We focus on edge computing applications as well as infrastructure and tools. And I'll talk a little bit more about that in a second. Our leader and founder is Dr. Satya, Professor Satya, a university professor at Carnegie Mellon, which is about as high as you can get. He's often referred to as the father of edge computing for a paper that he published in 2009. When everybody else was rushing to the cloud, he was rushing to the edge with the thought that latency really does matter for a lot of different types of applications. And it turns out that it just took 10 years for people to come around to his point of view. So we've been in this game for quite a while, recognizing particularly the need for low latency, high bandwidth networks in order to be able to provide the services that edge computing can provide. We focus on really sort of three areas of edge computing. One is what we refer to as edge native applications. What are those applications that can only really be done at the edge, that require that low latency or high bandwidth or some sort of privacy protections, or other reasons why something might need to be at the edge? How do you create those applications? So platforms and tools to be able to actually produce the applications themselves and load them into an edge infrastructure. And what does that edge infrastructure actually have to look like in order to support the kinds of things that users are going to want to do on the network? And we do that through a normal process of research and experimentation, publishing papers. But two things that are sort of unique about us in terms of how we operate: we do a lot of engagement with industry partners, because we like to make sure that what we're doing is grounded in the reality of what's actually going to be used in the real world. And they also give us a lot of good feedback on the kinds of things that they would like to see future work on. And in fact, our Magma, as I think Sean knows, our Magma engagement our Magma work actually came out of our engagement with Facebook connectivity a couple of years ago. And the other thing that's key to us is we focus a lot on open source code. So our primary artifact of the work is code that we contribute back into open source community, or open source more broadly. And of course, we do the other typical things that a research organization does, research papers and all sorts of demos and presentations. And probably our most valuable commodity is CMU graduates that go off into industry and help the rest of you do what you're trying to do. So that's who we are and what we do. Let's talk about why we have a mobile private network at all. We decided actually a few years ago, I'll give you the history in a minute, that we actually needed to have a low latency, high bandwidth mobile network that we could control completely ourselves. We found that the commercial networks really didn't work for us very well. They certainly work, but they gave us very long latencies, a lot of jitter, and very, very unpredictable performance when we were experiencing, or networks were experiencing network loads. And this is in part due to the mobile network itself, but it's also due in part to the interconnect between the mobile network and the back end edge infrastructure or cloud infrastructure. Without local breakout, our traffic here coming out of Pittsburgh was traveling all across, or it still is traveling all across the country when you get into when you're trying to connect from a mobile device back to our data center in Pittsburgh. So a round trip, this is one representative short example where we go down to Atlanta and back through, I think that's someplace in southern Illinois to get back to Pittsburgh. Many times these will go off to Texas or even Seattle before they return to us, even though the mobile device itself may be in the same room with us. It's the edge computing node, it still traverses the country to get across the room, which leads to very bad performance for us. And just as an example, here's the comparison of the kind of performance we get with our private network, what's referred to as the Living Edge Lab on the slides, and what we see from commercial vendors. I think this was a T-Mobile network, but it's pretty similar to what we see from AT&T and Verizon when we do it in our environments. And so you see two major effects in here. The left-hand side here is ping time, which everybody's familiar with. The right-hand side, though, is one of our edge native applications that is basically sending images up to the edge node and then back to the device. And so it's got a little bit more bandwidth stress that it puts onto the network. And you can see it here, two things. One is the mean latencies in the commercial networks are substantially higher than they are in our private network. And even more important for some applications, the jitter, the width, the standard deviation of those histograms is markedly different. And that's, in a large part due to that interconnect issue. So we need a private network in order to be able to get that performance in green on the right. This is for LTE. And as we move into 5G, which I'll talk about at the end here, we want to push all of this stuff to the left and get lower means and tighter histograms as we move on to 5G. So this is the diagram of our private network right now. We're deployed in and around the CMU campus here in Pittsburgh. We have 4 outdoor sites that were put in by JMA in 2021. This replaced, by the way, a previous network that we put in 2017 that was based on an experimental license for band 42. That had a lot of issues with it in terms of the equipment that we put in. We were talking earlier about maintainability. We just had no visibility at all into that network, and getting UE that would connect to band 42 in the U.S. was very problematic for us. So we basically retired that in 2021 and put in a brand new CBRS network with those 4 nodes. When we started our Magma work, we also deployed a small indoor network as well, with just 2 eNode Bs for the indoor effort. The initial network, this is what it looks like today. The initial network was based on a Druid core running on an AWS Snowball Edge that we had partnered with Druid and AWS to deploy. And I'll talk about the timeline for us replacing that with Magma, but we just last month retired the Druid core from its role as a backup core, and now we're entirely on the Magma core. So a lot of progress. We've got everything basically on Magma as our core going forward for both LTE and 5G. I do want to touch on, we were talking about rural deployments. I do want to touch on one project that's a research project we have going on that's based on the same technologies we have in the previous network, but that is really more of a project that we're trying to do. And this was actually motivated by discussions we were having with ARM to look at, what could you do for those environments where you have what I think of as no access network and no backhaul. You're dropping into a site. Let's say you're doing site inspection for a bridge, or you're doing search and rescue, or some other use case where you're dropping in temporarily into some remote environment with no access network or backhaul. And so you really cannot carry a lot of equipment into the wild to do this, nor can you afford a lot of power to do it, to run it for days on end. So we looked at what could you do in terms of integrating everything, all of the wireless infrastructure and all of the applications onto a single server. And we did that. We've got a prototype of that running, everything on Linux, Docker running in Kubernetes on a single server, running both the application, the Magma core, and it's not actually running the orchestrator, but more for a technical reason. The ARM orchestrator is not available yet, and this is an ARM server box that we have. So we've successfully deployed this with everything running under Kubernetes on it. So I can talk more about that if you want to during the Q&A. So it's a completely different sort of project. So let me talk a little bit about our journey here. As I mentioned, we got engaged with Shaw's team sort of towards the middle of 2021, right around the time we were deploying the current network. And they said, well, why don't you use Magma instead of Druid at that time? We said, well, we don't think it's maybe quite ready. We're certainly not ready to put it in yet. But we started an exploration on 1.6 at that point in time. And that we successfully got 1.6 running towards the back half of that year. And then we put it into the indoor environment that I showed you earlier at that point in time. Late 2021, early 2022, we just said, okay, well, why don't we just try it with the outdoor network as well? We just hooked it up to the outdoor network in parallel with the Druid core, and lo and behold, it just worked. It hadn't been tested with the JMA hardware at all. It just, out of the box functioned. So that was very encouraging for us. We left it in place as a backup core to the Druid, but over time we gradually used that more than we did the Druid core. When 1.8 came out in sort of mid to late 2022, we tested it out starting in probably September timeframe. This was a big one for us because huge believers in containerization and deployment based on Docker-based solutions. And so most of our applications are designed that way. We find it a lot more convenient. And after some of the struggles we had with 1.6 on bare metal, we decided that we really wanted to have the containerized version. So we deployed that. That was much faster process for us to roll out than the 1.6 process was. And so we put that in. And once it started once it was fully deployed, we basically deprecated the Druid core altogether and began running with Magma as our primary EPC. And just last month, we retired the Druid core completely. So we think we're, first, if not first, one of the first in a few different areas with Magma. I think we were one of the first to do a bare metal on-premise deployment, not virtualized. AGW deployment on a bare metal server, which was quite challenging with 1.6 due to some of the networking constraints that it had, and just the fact that if something went wrong, we had to start all over from scratch. I think we were one of the first to do containerized version, and I think one of the first to actually deploy a Kubernetes-based AGW, which we have running both in both networks right now. In terms of challenges, 1.6 was pretty hard. I don't recommend people using that. Now that 1.8 is out, it's a much more straightforward process to deploy. So to David, who was looking at a POC, I think building a POC is challenging, but it's certainly possible to do now, much more easily than it was a couple of years ago. And I made the comment to the TSC, documentation for users is not good for Magma. And by users, I mean someone like us who's actually a real end user who's operating a network. The idea, and we use a pure open source version, not the hardened one from Connect 5G. So I'm sure they've got outstanding documentation for it. The network setup is still kind of clunky, getting the networks, by this I mean the Ethernet networks, particularly to the AGW and out, is still quite complicated given its requirements, the requirements of what that network setup has to look like. Just constrains you when you want to move the core around and move the AGW around. And so that always takes us a little bit of time to set it up when we're doing a new deployment. And we're still figuring out, there's a lot of features in there and we're just not even touching yet. So we learn as we need to, as we do future things. So let me just do a quick on 5G. This is our year to start going to 5G. We have, our goals for it basically are getting low latency, local breakout, and we want to try out network slicing as a QoS enhancement for edge native applications. We're not doing anything with millimeter wave. That we see that as mostly, sort of short range IoT kinds of applications we don't pay a lot of attention to in any of our projects. So we're more focused on the CBRS bands and leveraging that further. We have a sort of a two-step process in 2023. We're going to do a deployment at a location. I'll just flash it up here. It's a brownfield site in Pittsburgh where we're doing some autonomous drone flight research, and we want to have a network coverage there to support that. And then we'll eventually, when that's proven out, migrate our existing network over to 5G. That's it. Any questions? That was quite fast.
Not seeing anything.
No, this
in
is
chat.
wonderful.
Oh, go ahead. Sorry.
No, this is Shah. I just wanted to ask a question related to, you have more about the 5G. So is the 5G going to follow a similar network pattern?
What is it
going to look like?
In terms of how?
In terms of coverage,
so
technology.
Okay. Yeah. So our goal for the new site it'll be 5G first, and we've mapped out the coverage. We're basically trying to get about a mile coverage out from the building source, because we want to cover one of the rivers in Pittsburgh and some forest land, so we can fly the drones over the rivers and into the woods. So that's a new expansion for us. We're just working with our wireless provider to figure out an engineering plan for that yet. But so on the existing network, when you roll that to 5G, we're just looking for a like-for-like replacement with improvements on the latency.
Okay, and one more very quick question is that what's the traffic like on this network? Is it all related to living edge only, or do you have any other light traffic as well?
No, it's all ours. We have it's very lightly loaded.
Got you.
You know,
Yeah.
at any one point in time, we have probably fewer than 10 UEs connected to it because it's purely used for research purposes.
Got you.
And coursework.
Fantastic.
You know, we have students. Somebody asked a question. You know, we run an annual course in mobile edge computing or mobile pervasive computing, and we often have student master's degree and PhD student projects that are done on that. And then we have PhD students who are doing projects that utilize the low latency connectivity.
Okay, super. Thank you.
Jim, there was one more question in chat from Lucas.
Yeah, I put some notes in when I did 1.6 and I didn't update them for 1.9. I can share those with you. And then, you know, if you want, I can spend some time to try to like tell you what I would want.
That would be great. Thank you.
Yeah. Okay. Thank you.
Awesome. Thank you, Jim. Alrighty, next up, we've got Javier from Yoto de Nicaragua. So Javier, also please just do a quick introduction of yourself for folks, and then we can jump in.
Hi, everyone. Good night, good morning, good afternoon. I'm Javier Albert. I work in Yoto de Nicaragua. We are a small internet service provider here in Nicaragua. And we have been working with Magma for a few years now. I believe since version 1.02 or 1.3. And we have been updating our setup since that version. We are now on 1.8. We have a small commercial network. We have a few sites, a few Inuits B, and deployed in a region of our country. And so we have commercially clients. And tonight, for me, I'm going to talk about my experience and the experience of the company deploying the orchestrators. So this I'm going to share how we do it here. I believe. Can everyone see my screen, right?
Yes, we can.
Okay. So first of all, the orchestrators are a very important part for the Magma deployment. They are the ones who control. They have control the access gateways. They are the ones who, in case you are using their local subscriber DB, they are the ones who holds all the IMSIs, all the information of the IMSI. You can set up policies and that kind of stuff on the orchestrators. You have the NMS and you have the API. So this is really very, very important. And in the beginning, for us and for me in particular, it was a really a little bit tough to deploy the orchestrator. So now I work on steps that I made to deploy, and I want to share with everyone. So anyone like the new people in the community can have also an experience to compare. For example, on the documentation, you have run this script, but sometimes you don't have like a photo or on a screen what to expect from running that script. So I try to here to do that, to capture all my steps and share my results. So you can see step by step how we how we deploy the orchestrators. So first of all, of course, you have to install the Docker engine and the Docker Compose. And I'm here. I use the latest version of the Docker engine and the Docker Compose. However, um, um, to build the orchestrators, at least until version 1.8, you have to use a specific version of the Docker Compose. So sometimes, maybe when new people want to build from the sources, the orchestrator, you might have um, an error trying to use a different version. So, however, I try to I'm sharing here the Docker Compose files that I use, so you can run in without any trouble. And here I am using the latest version. Also, I'm creating here some directories, and you can see that I can, what I do is to copy from the GitHub repo from Magma, of course, version 1.8. I copy several configurations files, several files to the folders that I have previously created. These folders will be my volumes for the containers. Then I use this script that was made by Dimitri, who is here, by the way. And this is just to create certificate, because the orchestrator work with certificates. You have here you can create the root C8, which is the certificate you load to on the access gateways or on the federation gateway to enable them to connect to the orchestrators. So here is just and a script who creates certificates, and of course they put them here on this folder, which is the one that I am putting here all the certificates. And then we create the certificates for the Docker engine. Of course, the orchestrators have an NMS key, and this NMS key, actually, when you connect to them, you are actually connecting to a proxy, an engine proxy. So this certificate is for the uh, engine proxy. So you can see, you can use the NMS key. Of course, this is a command to self-generate a certificate. However, you can, if you have your own certificates, you can put them here in this folder, and you can you will not see that message that says that this site's not secure because it's a self-signed certificate. Here you can put your own certificate, for example. And also you have to create the certificates for the FluentD service. Here is that part. I must say that I had, in my experience, I had it was a really tough part to me to run the FluentD, because actually these lines or this procedure, it's kind of high in the Magma documentation. So it was in the beginning, it was kind of hard to me to deploy, but here it is now. You all can use it, and it's easy. So here, the Docker Compose files. Here, these are the ones that are in the Magma repos, with a little tricks, of course. For example, here I'm using the image that I built. Also, on the Postgres, I'm using a volume. You see, I'm using a volume. So wherever I down the containers or up the containers, I keep all the information of the database. I want to say that this is a very basic version of I mean, not a basic version. I wanna this is a not this is kind of file for like a testing on an early deployment. If you want to bring this to production, you have to, of course, add more layers like Jordan's sharing in his presentation. You have to add fault tolerance, so you will need more than one servers. How we do it here in Jota, we have several servers. We have two physical servers. And we have there some virtual machines. We have 3 virtual machines per server, and we have a Docker's farm. We running this in a Docker's farm, so we have full tolerance to any issue. We have so I have here the Docker controller, also the Docker Compose NMS for the NMS key, and also the Docker Compose metrics, which are the ones that appears on the Magma documentation, on the Magma GitHub repo. I'm sorry. I want to share that there is one issue. If you run the container, the Docker files that are on the Magma GitHub as they are, that will run. However, and we have the issue that or these were getting filled by logs. So after a little bit of research, I found this. Okay, I want to share with you. Here, I found that you can add this configuration, these parameters on your Docker compose files, and then the logs will start to rotate and delete itself, and this will not fill up. I remember that we had an increaser of about 20 gigs per 3 days or something like that. So these lines will help a lot of people to especially for testing when you are using no so strong hardware, to avoid this issue with the logs. Of course, you can also, if you want, you can delete the logs manually, but I believe this is going to work better. So these files are the ones that, like I said, all this have been took from the Magma GitHub, and now Docker Compose controller app. As you can see, I'm using version 2 here of the Docker Compose plugin. So and this is running. And next step, I want to say, I need to mention that first you can run the Docker Compose controller and the Docker Compose metric first. However, the NMS must be up later, because before to run the NMS, you need to create some certificates, and these certificates will store on the database some kind of info. And when you write also you will need these certificates. These certificates are the ones that on an NMS are configured here. So you will need this certificate, the admin operator certificate. So you need to first create this, and this is created on the controller container, and then you can run the Docker compose nms up, and now you can proceed to create your first user. This is like your master user. I run this entire guy, and it took me about 20 minutes to have an orchestrator installed with the first user. I create the first organization. You can see here I did it previously. You can see by the domain, this is host.testing.com. Of course, this is a test. And I create the organization, and here is the network for that organization. You can see here I'm on testing.com, NMS, and this is pretty much a really straightforward guide to have an orchestrator up and running. You can now add an access gateway or a federation gateway. You can add subscribers here, and this was made a few moments ago following this guy step by step. So the new person who are watching this, or the new person who will see this later on another day, you can have your own orchestrator. You can start testing things. You can start to familiarize with the Magma. This is a really important. This is a very important part for all of us. So that's what we want to share with all of you, how we do it. As you can see, this is a very straight forward procedures, and here is what you will obtain after running of the steps. Also, I have an example here. Just a few moments. I have an example of deploying an orchestrators on a DigitalOcean droplet. So here are the captures, screenshots of all the steps that I made. So you can see the containers getting rise and all the message. And at the end, you can see the screenshots of the NMS key. Also, the results, captures from the results of all these steps and commands and script. All the results you can see here, so you can compare, you can share, you can also see if you have any problems, or what info if we have, or you can compare your 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 um, your setup with a reference. You can have this as a reference to try to better understand, or try to fix. If you are already trying to deploy the orchestrator and you're having any issues, you can see here the results that we have and how we achieve to have the orchestrators up and running. And that would be all from my sides. I see there are a few questions, but Benjamin, I will switch to
Yeah,
you.
there was a question from David that I think Jordan had addressed, but what we can do is We have some time at the very end. I just want to make sure we have enough time for the next presentation. If that question that was asked in chat wasn't addressed, we can address that there. But so far, that's the only one I've seen. Okay, thank you, Javier. That was great. All righty, next up here, we're going to hear from Hjordan again, and also from Yogesh from Wave Labs.
And I'm starting to share my screen. Hopefully you can see the screen. Yeah, yep. And it seems that I started from the last slides. Okay, so I will be speaking a little bit about where is now the community and what are the next steps for the community from the perspective of the TSC. Up to now, or up to a certain point of time, the community was mainly driven by the big companies who were starting from Meta, ARM, who were the initial founders of the open source community. However, now we are transitioning to the to the community-driven projects instead of big companies-driven projects. And we are happy that this transition is ongoing successfully at the moment. We didn't experience any issue during the transition. And we are seeing that more and more strong cases of the ownership of the Magma code and ownership of the Magma use cases and collaboration between the users of Magma and the developers of Magma is emerging. And as a TSC, we will try to improve this communication, and we will try to make it even better in the future. As you have seen from some of the deployment cases, 1.8 reached the maturity. The community version still has some bug fixes which are going to be addressed in the next release. However, the 1.8 is already very mature, and it's capable to be deployed in serious commercial scenarios. So the community contribution and engagement, it's growing. We are not seeing that much on the code contribution, which we would like to see more code contribution growing as well. However, the contribution from the community members on the feedback, on the helping the other community members deploying and testing the solution, or answering the questions and helping them to resolve their problems is growing, and we are happy to see that trend. From the TSC committee, we have introduced working groups where not only the TSC members can discuss about the specific issues and the focused issues, we are inviting all the members to join these groups, put your voice in these groups. We are going to gather the feedback, and then this feedback from the TSC members who are part of the working group will come to the TSC, and then the TSC can take actions or can steer the next actions into the direction from the suggestions which are coming. We have introduced up to now the features working group, which Yogesh is leading, where we can discuss about new features and what new things needs to come to Magma. We have the security working group, which is led by Lucas, where we are discussing the security features of Magma, how to make Magma more secure and more resilient. We have the outreach group, which Som and me are leading. You can come and talk to us how to bring Magma to another use cases, how to create new proof of concepts, how to talk to new universities or to other communities, and expand the knowledge and knowledge about Magma and expand the Magma community. And there will be more working groups to come. As we are progressing, we will create more and more working groups where the users can find themselves and help to contribute to the community. So in this town hall, we are very happy to introduce some new initiatives which we are running from the TSC. One initiative is the Magma Starter Kit. Then we will run we are creating a bounty program. We are launching the GitHub discussions, or we are relaunching the GitHub discussions because they were already there, but we were not focusing on using them. And as you have heard from many people here, we have issues with the documentations, and we need to seriously improve the documentation in order to help the average users who are starting to use Magma to be able to more smoothly start using Magma. Going back to the starter kit, we are discussing with Hawkeye Tech to build a special device only for the Magma community, which will be based on CN9130, which is a 4-core SoC ARM. And we are going to put the community version on this device, or also we can put some of the hardened versions from the community partners which have hardened versions on this device, and ship it to the users to have the quick start. So basically, this device will be prepared, pre-provisioned. Everything will be ready to be integrated with Orchestrator. You will need just to put IP address for the orchestrator, where the orchestrator lives, and then the device will connect to the orchestrator, and you can start using the device. So you will no longer be required to fully analyze and understand how Magma is deployed. You can just take the device and start testing your networks. We are also going to try for this starter kit to find a suitable starter radio, in which case you will have the full network coming to you. You will just fire up the network and you can start testing your use cases. We are introducing a bounty program. We like to engage the students and new coming developers to contribute more to the Magma code. And we are planning to do this by creating small chores or small bounty items based on as a feedback from a different working groups. And then these bounty items are going to be offered to the whole community. Whoever wants to address that bounty item, if he addresses it successfully, this will be verified and he is going to claim the bounty. Some of the bounties will be more symbolic, but some of the bounties which are coming for the more serious issues will also be significant, especially for the students. So I'm encouraging all the students to follow the development on the bounty program and use it to get extra revenue, which is a student you will really need. Then, as I said, we were relaunching the GitHub discussions. Up to now, all these discussions and all the help between the community members goes actually on the Slack channel, which is good, but Slack is not that good in searching and finding the new things, especially the issues which are addressed on the Slack are not actually searchable through the search engines like Google. So we like to bring everything back, all these discussions back to GitHub discussions, which is the tool from GitHub, especially for this type of things. And we like in these discussions to move some of the history and all the community members in future to continue to use these GitHub discussions, so we can further improve the knowledge base around the product. We also participating in this discussion. Actually, it will be quite good for even for the starting users. I mean, just find some small questions which are not answered. Try to answer them. By answering them, you will also learn something. So you will have opportunity to explore the code or explore the product from the certain aspect, and then you will learn more things, and then you can help some other community member to solve his problems. And then once again, as everybody is saying, we have problems with the documents. We have problems with the architecture documents, which are creating barrier for the new developers, which we need to improve, and we have problems with the end user documents. So we need to start as a community focusing on improving these documents. We need there was a very good initiative from Magma India, which unfortunately is still not merged into the main stream of Magma as a documentation, where they have created quite a good and quite detailed flowcharts of how the communication between components is happening. But also we want to see this type of details for the internals of the components. So the new developers could be able to understand how the components are working and how to extend the components. And we want to build Magma in a way that we will allow multiple components to be replaceable. By example, at the moment, we are using software-defined network based on Open vSwitch, but there is initiative to go with eBPF, and we like to be able to have the Open vSwitch component, which is the pipeline D, being interchangeable with the Open with the same type of pipeline D, but running now on eBPF, without changing on the rest of the components and rest of the architecture. To do this, we need to standardize the communication between the components in the form of what type of messages and in which scenarios these messages are exchanged. And then the developers will be able to build additional components which are going to interchange some of the existing components, and therefore making Magma more versatile and make Magma support much more use cases. Now about the roadmap, I will just introduce the roadmap and then hand over to Yogesh. We are preparing version 1.9, and the release, we are targeting the release of 1.9 in mid-August. And at the moment, we are working to build the code for this release and to start testing. So we are inviting all the community members to help us in this building and the testing of the 1.9. What 1.9 comes, I mean, Yogesh, you can help me and explain what we are going to see in the 1.9.
Sure. Yeah, I'll try to be quick. Key features which are planned for 1.9 as performance improvements. We have got a lot of feedbacks on these improvements, and we are trying to use like protobufs and structure to improve the performance. Also, there were some portion of C which was there, so we are the 4G part is completely getting migrated to C++ code, where it is making it more efficient. The 5G SA code is hardened on the containerized solution, which was there in 1.8, but it was only for 4G. The 5G version will be hardened on 1.9, and we have tested with new GNBs, the Tier 1 GNBs, and we have tested NSA specifically. There are a couple of critical issues which we got as part of 1.8, and that's addressed in 1.9, let's say related to SCTP or some other events. And also we are working on improving the logging so that it becomes pleasant to use the Magma. That's all from my side, Jordan. Back to you.
So you can follow us on the thank you, Yogesh. You can follow us on the PN 15.12.7, where we are discussing the 1.9, and you can also give us your feedback from if you are testing and building 1.9. Give us the feedback for the defects or feedback for the whole experience from 1.9. By arriving at this point, Ben, we need to go quickly to the Q&A, and I need to stop sharing so I can read some of the questions. Yeah, back to you, Ben.
Yep, so we've got, let's just do a couple minutes for Q&A because we're running a little over. So yeah, open forum for question and answers for anything that, for any of the folks that presented.
Okay, there's no question in 5 seconds. I'm going to ask one.
Go for it, Shah.
I have a question after.
Okay,
so
yeah. So a question for Jordan and Yogesh about the eBPF. I think I just saw a communication. So keep me honest here. Is that I think one of the eBPF maintainers, Praveen Scheller, who used to be at Meta, not at Meta anymore, he has offered to help pull together the eBPF design. Sorry, like it was already designed and there's some progress made, but just kind of productionize that or kind of pull that into fruition, has offered to help. So is there some activity already ongoing? I mean, it feels like it would be a high leverage, high pro product, feature.
Yeah, up to now we had the discussion only, but we are now moving seriously to eBPF. So this comes from the outreach working group. So we are going to expedite the work on the eBPF. I know that from the future working group as well that there is something discussion on the eBPF.
Yeah,
Okay, fantastic. Yeah.
there's a lot of interest on that, and there's a Praveen has put together the starting document, and just as of today, we have started working on it, and they said let's just start working on planning the project together and so on. And it's not fully staffed in terms of code ownership yet, but the work has started. It's a popular project.
Okay,
Yeah,
that's
correct,
awesome
correct.
to hear.
We have the
Yeah.
initial design. We have the initial design, and then we just need to see how we separate this into working packages and start running the project basically. But yes, this is something which we are very excited.
Awesome, thank you.
I have a question for the students and new people. I know that Raul was going to invite some students from his world who were in need of a demo and kind of a shim to get started on the project. And Javier's talk and just overall all the work he's done. I think we're hoping that that'll kind of get these folks what they need to get a bootstrap. I wonder if we can talk about that and make sure that they have what they need to move forward.
Thank you. I'll be happy to share my thoughts. Tonight we have David from El Salvador, who he shared his background in terms of network engineering, and we've been talking for a while because he has a community where they have attempted a similar project having to do in enabling the education community. And so currently we're working at the University of El Salvador with a handful of students in the networking group. And so at least 2 students are very committed. That's the best word to use in order to find a way how to deploy this Magma, so that whatever they learn in the next 90 days, they can then share their learning on a conference that we're putting together in September 30th. The idea is to get the students interested in contributing to open source, and so that it will be a way for them to be part of the solution. And as that will be one function. The second function, the university, it is in the east side of the country, which is very rural, and so it would be ideal to try this. And then last, it would be probably to serve the community as well, right? Not just the students, because right now there is always a need for a better connection. So that happens at the university, but then I would say that the community itself can benefit from this. So I think that David kind of articulated a little bit about what his vision is. And so we're going back to watch this in more in more detail. Diego Herrera, who's the professor there, attended the meeting briefly, just for a little bit. So he wants to now take the time to digest all of this, and perhaps we're open to also collaborate with other universities as well. I'm working on reaching out also to the University of Southern California, and then I also reaching out to Jim through the Slack to see whether we can come up with some ideas to really strengthen the program there. Why not?
Great.
So any ideas, I think would be happy and happy to see that perhaps we can collaborate with Javier. So he's very close. I mean, Nicaragua is probably very close from San Miguel, which is the area that I'm talking about for El Salvador. So I think we need to start, reaching out to each other as well.
We have question from David, how we can simulate the E-Node B. There are several ways where you can simulate E-Node B. Simplest one is using SRS run at the moment. And we are planning to do a special demo just maybe in the next town hall meeting or maybe even sooner, just how to use all these simulators to simulate the E0BIS and the G0BIS.
Okay, we probably have time for one last question if there is one. David says thank you, by the way, Trevor. So
hello, guys.
Go ahead.
Can you hear me?
Yep.
Mm-hmm. Yeah, I don't have much of a question, just something to add based on everything showed today. Mostly what Javier have showed to us, it's a way of sharing the knowledge of how to build the orchestrator and everything else. And I'm seeing the importance of everything about it. I spoke with Jordan a few weeks ago about it. And once I've learned everything from the GitHub, I've just created my own account there. And I will try to create some content based on what I have spoken on the last session from you guys, that I have built my own orchestrated AGW and everything else at home. So I will try to contribute with that. So with the way I managed to make it at home, I think lots of people will be able to visualize a way to make their own. And I think that way will be a first step for most of people that want to join this. So it might be a step for some people.
That's awesome.
Yeah. Thanks, Igor. I'm definitely it will help a lot when we start putting more and more from this personal experience. It will help the new users, because as a new user, even I remember when I initially started to look on the documents, it looks scary. So yeah, we need to make this very pleasant experience.
For sure, yeah. Look like easy for the normal people. You know, I think I can help with that.
Yep.
Or something you could do that would be useful would be just to write up notes on what your experience was like and what the blockers were.
Yes, I got a lot of notes because I have like more than 10 tries, and from starting from scratch, everything over and over again for a few weeks. And at the last day, Diego is here. Diego Ribeiro is also here. He helped me achieve, the whole thing working, and it was, mind blowing. I saw everything working, and I just want to help people achieve this as well. It was a huge challenge to make everything work, and I got notes about everything. So I'll try to find a way to share this on GitHub, and maybe it will help the newbies like me.
That's awesome. Okay, just to close this out here, hopefully folks can see just a couple important links here for people that are really important for the project. So we've got a wiki with a lot of meeting notes and other project artifacts. It's definitely a good place to poke around. Obviously, GitHub, where the code is incredibly important. The discussion area that Jordan mentioned before is there. Slack, of course, is where a lot of things happen. So I'd encourage folks who are interested in the project, joining Slack is probably your step one. And we have a shared calendar where you can see when some of those working group meetings are, if you wanted to attend any of those. So I just wanted to leave that up while I kind of close this out. I wanted to thank all the folks that presented today. I know presenting is a lot of work, and I think it's fantastic, the content that was here today. I also want to thank all the attendees from around the world who attended today. Great discussion, great Q&A, and stay tuned for the next town hall, which should be happening next month.
So thanks everyone for joining.
Thanks everybody.
Thank you, everybody. It's great to see everybody. Thanks.
Bye.
Bye-bye.
Thanks all.
Thank you, everyone. Bye.
Thank you.
Thank you. Bye.